So hello everyone, this is lecture 1 for the general aptitude. This subject is very helpful for scoring marks in the exams like NET and GATE and all. And the syllabus is same in all the exams. So it will be a very great boost to your marks. So study it through my lectures, of course. So let's see first topic, that is number system. So let's see first numbers, about the numbers. So numbers are two kinds. There are real numbers and imaginary numbers. What are real numbers? So any number which can be represented on a number line. It can be a fraction, it can be an integer, it can be a decimal point. All are real numbers. Means which can be represented on a number line, means x-axis. All they are real numbers. But if they can't be expressed on a number line, then they will be imaginary numbers. I hope you know about this imaginary number. We need to put this imaginary number on the y-axis, the imaginary plane. Okay, so this kind of numbers where it is minus inside the under root, these numbers are called the imaginary numbers, where we introduce this iota and this I square equal to minus 1. Okay, so complex number is nothing but sum of real and imaginary, and this part is imaginary. So these numbers are imaginary numbers. So you know how we can write this under root minus 7. It will be under root minus 1 into under root 7. So this will be iota. So this is iota root 7, the imaginary number. So this was the introduction for this. Now let's see the more about real numbers. So real numbers have two kinds, rational numbers and irrational numbers. So rational numbers are those numbers which can be written in the form of p upon q, where q should not be equal to 0, otherwise it will tends to infinity. So that's why it can be written, it should be written in this form. Only then we call it as rational number. P and q should be integer. So these all are rational numbers, and this is also a rational number, means non-terminating but repeating rational number. Okay, so if it is not repeating, then we call it a rational number. So 22 upon 7, this is also a rational number, and root 9 is also a rational number. So this can be written as 3. So irrational numbers can't be written in the form of p upon q. So if this is irregularity after the decimal, so these numbers come under irrationality. So under root 2, under root 5, all the numbers under root will come into irrational numbers, because they doesn't repeat and they will go to the ends, means they don't terminate. And pi, this is pi. So this is also a irrational number because it is non-terminating. We call this 22 upon 7 pi, but this is just approximately equal to pi, because pi is irrational number and 22 upon 7 is rational number. This number will repeat after 5 points, but this never repeats. So there is a difference, only one. Now see decimal numbers. We have terminating decimals like this, and non-terminating repeating decimals like this, and we have non-terminating non-repeating decimals like this. So these are the irrational numbers, and these both contains the rational numbers. Okay, now let's see integers. There are negative integers and non-negative integers. So non-negative integers include 0, and other than all numbers are called non-negative. It will go from minus 1 to minus infinity, 0 to infinity. And these non-negative integers are also called whole numbers, because whole numbers are starting from 0, 1 to 3 and all. So 0 neither positive nor negative. Natural numbers are starting from 1 and to infinity. Integers can be even and odd. So even are which can be divisible by 2, and odd which are not divisible by 2. So there are some examples given. Now you need to remember these things for the fast calculation. Any two number which are odd multiplication will give you odd number, and odd and even will give you even number, and addition and subtraction of two odds will give you even number, addition subtraction of even will give you even number, and odd and even will give you odd number. So these are very important things. Now natural numbers can be divided into two forms, that is prime numbers and the composite numbers. So what are prime numbers? Those have their factor as 1 and only that number are called prime numbers. Like 3 has factor as 1 and 3 only. Only two factors, that is 1 and itself. So we have like this, these are prime numbers: 2, 3, 5, 7, 11, 13, 23, 61, 7. 2 is even prime number, only one even prime number exists, which is 2, and it is the smallest prime number. And there is this only one pair of group exists, 3, 5, 7. Only one group exists of consecutive odd prime numbers, 3, 5, 7, means there is only difference of 2 in all the threes. 357. And remember this, from counting 1 to 50 we have 15 prime numbers, 50 to 100 we have 10 prime numbers, 1 to 100 we have 25 prime numbers, 1 to 200 there are 46, and 1 to 1000 we have 168. So these numbers are very helpful for the reasoning and all. Now each prime number can be written as in this form, but it doesn't need to be true that all numbers represented in this form are prime numbers, but each prime numbers can be represented in this form. Okay, so but every this form may not be necessarily prime number. So you can see if k equal to 1 it will be 7, and if it is minus then it will be 5, and that's how you can see. Now composite numbers are all numbers which are not prime numbers are called composite numbers. So in other manner we can describe as more than two factors there are, means other than these two factors, 1 and itself we have one more factor, then we call it composite number. So 1 is neither prime nor composite, 4 is smallest composite number, and 9 is smallest odd composite number. Now there are co-prime numbers exist. So we have prime numbers which have one their SCF, but if there are two numbers exist which in common there is no factor exist, then we call them co-prime. Like this 4 and 9. In individually we see that these are not prime, but if we take these two together their SCF will be 1, means they can't be common out with or factor out with any number. So these are co-prime numbers. So SCF should be 1 to call the one pair as co-prime. Okay, also called relatively prime. Now there are perfect numbers. If the sum of all the factors excluding that number is equal to that number, then it is called a perfect number. Let me give you an example. Like 6 factors will be 1 2 3 6. So exclude this number, then add these numbers 3 to 5 and 6, it will add up to this number again. So we call this number as perfect number. So this is smallest perfect number, that is 6, and 28. Sum will give you 28 excluding this. Now perfect numbers are example 628 496 8128 and all. So remember this. Now let's see divisibility rule. Now any number which ends with 0 2 4 6 8, last digit is this, so it will be divisible by 2, so you can check it directly. And if any number add the all the digits of that number, and if it sum will be divisible by 3, then we call that whole number divisible by 3. Okay, or for fast calculation you can see that if 2113 divided by 3, 549 divided by 3, 9315 divided by 3, then the whole will be divided by 3. So that's how you also can check. Now divisibility by 4, the last two digits should be divisible by 4, then we call that number as divisible by 4. So if there is 0 5 in the last digit, then we say that that number will be divisible by 5. For 9, or sum of all digits should be divisible by 9. For 8, the last three digits should be divisible by 8. Okay. For 11, it is interesting. Take the alternate numbers. Means if you are taking this, then take all these one, leaving one behind. So all these alternate numbers, add them, then take the remaining one, add them, then take the difference. If that difference, absolute value of that difference is divisible by 11, then we call the number as divisible by 11. Whole number will be divisible by 11. It can be, if difference came out to be 0, it will also call the divisible by 11. Okay. Now there is this rule. This is very interesting rule. To check in one go, you can check whether it will be divisible by 13, 7 or 11. Okay, all three numbers can be checked. So you need to follow this rule. Make pairs of 3 digits from right hand side. Any number given, make 3 digits pair from right hand side. Then add alternate pairs and take difference. Now what this means, take the alternate pairs and take difference. Like we have this number, forget these 2 zeros, we have put these 2 zeros to make this whole 3. So from right hand side we are making 1 2 and 3 pair. Now alternate pairs will be this and this, so sum these pairs and subtract this. So sum of this will be 891, sorry, sum of this will be 653 and subtract 891, so we will getting some difference. Okay, so that's how you will make the pairs and take the difference of adding these and subtracting the alternate. Okay, if you are having only 2 pairs of 3 3, then subtract them from one another. So what happen after subtraction? If difference is divisible by 7 11 13 respectively, then number will be divisible by 7 11 13 respectively. So difference will came out, and check if it is divisible by 7, 11 or 13. So whichever dividing that difference, then that whole number will be divisible by that number. Okay, so let's see one example. Like this is different, this is, so make pair from this side, 1 2. So take the difference will be 91. So 91 divided by 13 and 7, but not by 11. So this whole number 579488 will be divisible by 13 and 7. Now take this number 1352, make pair, 1 pair, and again this will be second. So take the difference, subtract this from this, you will get 351. So 351 divided by 13 but not by 7, not by 11. So this whole number divided by 13 but not 7 and 11. Now take this, so this 1 pair, 2 pair, take the difference, check if it is divisible by 7 then this whole number divisible by 7, if not then 11, 13 not. Now this was whole number, take the pairs 1, 2 and 3. Now take the alternate pairs, this will be, so add these two, subtract this, take the difference and check. Now this is the number, take the 1 pair, 2 pair and 3 pair, sum these two and subtract this one. So you will get 0 here, and 0 is divisible by 7, 11, 13. Then you will see that this whole number is divisible by 7, 11, 13 completely. So this is a very interesting rule. Remember this is very useful also. Now there is this remainder theorem. So if you are dividing some number, this is called divisor, this is called quotient, this is called remainder, and this is called dividend. So this dividend equal to divisor multiplied quotient plus remainder. This is the rule. And remainder will always less than this divisor. This is the rule. And see, if you are dividing 210 by 45 and you want to know the remainder, so just first factorize this, you will get 14 by 3. So we factors this by 15. 15 3 is 45 and 15 1 4 will give you 210. So now it is easy to check the remainder. 3 by 12 you will get 2 remainder. Now this is the remainder of this. For real remainder, you need to just multiply that factor. That was 15. So multiply with 15 here, you will get 30 as your remainder. So remember this formula, very important. So we'll meet you in the next lecture. Thank you.